Fundamental Theorem of Calculus Part 2 is what we figured out by plugging all these numbers in here. We plugged in 6 and 3. We plugged in 3 and 0. We plugged these numbers into what was the antiderivative of the original function, which tells us that the area is equal to the antiderivative at the bigger number, or the top, minus the antiderivative at the bottom. Here it is. Now, why don't we add C, you ask? Well, what would happen if you did add C? When you plugged in B, you would have plus C. When you plugged in A, you would have minus C, and it would disappear. So we don't have to worry about the plus C like we do for general antiderivatives. Okay, let's do some practice. Fun stuff. Start with a simple polynomial. Integral from 0 to 1 is equal to 1 minus integral of 1 minus 8v cubed plus 16v to the 7th power dv. So step number 1 is to find the antiderivative. Antiderivative of 1 is v. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. And then we draw a vertical line, put the lower limit at the bottom, the upper limit at the top. That says we are going to take this function and plug in 1 and subtract off what we get when we plug in 0. So I have 1 minus 8 over 4 gives me 2 times 1 to the 4th power, plus 16 minus 8 gives me 2 times 1 to the 8th power. And when I plug 0 in, I'm going to get 0 minus 2 times 0 plus 2 times 0, which is a big fat 0. I love it when it's 0. So we have 1 minus 2 plus 2. My final answer is 1. You can check these by plugging them into your calculator. We'll do that with this one. Turn it on. Second integral. So second button here below the second button. We're going from 0 to 1. Your calculator does not want v's. It has a dx there. It wants x's. So we have to put 1 minus 8x to the 3rd power arrow plus 16x to the 7th power. I got it right. It's 1. Yay. I like it when I get it right. So on test day, you are welcome to check your answers, but I'm going to need to see the antiderivative. I'm going to need to see you know how to plug the numbers in. Now, if it's plugging 0 into something that's going to give you 0, you can just write down 0. Let's do another one. Of the integral from 1 to 8 of x to the minus 2/3. So add 1 to the exponent, divide by the new exponent. Add 1 to negative 2/3, I get positive 1/3 over 1/3, evaluated from 1 to 8. Well, 1/3 sitting on the bottom is the same thing as a 3 sitting on top. I'll plug in 8. I get 8 to the 1/3 minus 3 times 1 to the 1/3, which is 3 times 8 to the 1/3 cube root of 8 is 2 minus 3 times 1. Now you notice I gave 3 to each term there. You could pull 3 out front. Just factor it out and then do cube root of 8 minus cube root of 1, which would be 2 minus 1, and then multiply by 3. Same darn thing. Okay. I'm going to let you work on 26. I'll come back and go over it in a moment. I'm going to get you started on 28. So 26, leave some room for that. We do not have a product rule for integration. So in order to deal with the integral from 0 to 4 minus t times the square root of t, you need to distribute that square root of t through the parentheses. So 0 to 4, then you would have 4, and I'm going to write it with a rational exponent. T to the first power times t to the 1/2 power, add the exponents. So finish these two up, we'll come back and compare answers. How'd it go? Two ways actually to do number 26. We learned that property of integrals last time that it said if you have the integral of a constant, it's just the constant times b minus a. Or you can think of it as the integral, the antiderivative of this constant is the constant times x, evaluated from -5 to 5. Either way, you get 10e. This one, straight out power rule, add 1 to the exponent, divide by the new exponent. Then I take the square root of 4 is 2. 2 to the third power is 8. 8 times 8 is 64. Square root of 4 is still 2. 2 to the fifth power is 32. 32 times 2 is also 64. Common denominator is 15, and I end up with 128 over 15. Okay, let's do some more. We'll do number 32 together because it has a trig function in it. So we're going from pi over 4 to pi over 3 cosecant squared of theta d theta. So what is the antiderivative of cosecant squared? Well, cosecant's partner is cotangent. We always have two secants or cosecants and one tangent or cotangent. And with cos, they're negative. So this is negative cotangent of theta evaluated from pi over 4 to pi over 3. So negative cotangent of the top, pi over 3, minus negative cotangent of the lower limit, which is pi over 4. Cotangent is cosine over sine. Cosine of pi over 3 is 1/2. Sine is square root of 3 over 2 minus cotangent of pi over 4. I like pi over 4. Sine and cosine are the same. So it's just 1. So 1/2 is actually 1 over square root of 3 minus -1 because it was negative cotangent. I'd be happy with that. I think WebAssign would be happy with that. If you needed to, you could get a common denominator, or you could even rationalize the denominator. If you rationalize the denominator, you'd get square root of 3 over 3 plus 1. So you'd end up with 3 minus the square root of 3 over 3. I'm fine with that answer. Okay. I'll leave number 34. I will get you started on 36 and 40, and then we'll finish up 34, 36, and 40 and compare answers. So 36, that's 34. 36 is the integral from 1 to 18, and I'm going to rewrite this just to make it more clear. First off, I have a square root of 3 over z. I can divide it into square root of 3 over square root of z. Square root of 3 is just a number. It's a funny looking number. It is an irrational number, but we still treat it like any other number. It's just a constant. And this is really z to the minus 1/2 power. So, got you started. You can go from there. Number 40. 1 to 3. There is no quotient rule for antiderivatives, so we will divide it into pieces. Y cubed gets to be divided by y squared. 2y squared gets to be divided by y squared. And y gets to be divided by y squared. So I'm going to let you have a few minutes. We'll come back together and we shall compare answers. Fine. Starting with 34, the antiderivative of sine is negative cosine. So we plug in 3. The antiderivative of e to the x is e to the x. So we plug in 3, we plug in 0. And yeah, I would actually want you to go ahead and combine that into a 3, but I ran out of room, so I figured you could do the arithmetic. Next one, square root of 3 hung out in front. When I added 1 to the exponent and divided by the new exponent, I got a 1/2. So 1/2 on the bottom became a 2 on the top. And then I plugged in square root of 18 minus square root of 1. And square root of 18 is 3 times the square root of 2. It's 9 times 2. Square root of 1 is 1. Divided it into pieces. I had to take the antiderivative of y, antiderivative of 2, antiderivative of 1 over y, natural log of the absolute value. So our integral goes from 1 to 3, plug in 3, plug in 1, natural log of 1 is 0. I have 9/2 minus 1/2. That leaves me with 8/2, which is 4. So I have 4 minus 6, which is negative 2 minus negative 2. Everything goes away except negative natural log of 3. Hopefully those went well. Last thing they do here in this section is just bring everything together, put them in one big box together. So we have continuous functions on a closed interval. Then integrals and derivatives undo one another, and you can calculate a definite integral by plugging in the limits of integration into the antiderivative. You have now learned the fundamental theorem of calculus. Go forth and integrate.